So the question now we're going to look at is from 2013 pre-response, and it's a no calculator question, and this question is related to fundamental theorem. And okay, so in here we're given a graph and we have the measurements of the areas and everything. So the first one says find all values of x on the open interval from 0 to 8 for which the function of f has a local minimum, and then justify your answer. So in here we see that f has a local minimum. So first of all, what's the local minimum? A local minimum is when the f prime of x goes from negative to positive. So we can see in here f prime of x goes from negative to positive on when x is 6. So for a we're gonna write, let's go for a, we're gonna write at, excuse my writing, x equal to 6, f of x has a local min because f prime of x goes from negative to positive. And in here you get 1 point for writing x at x equal to 6 and doing the justification. So if you just write x equal to 6, you're not going to get any point. You have to write the whole thing to get the 1 point you have in here. Now look at B. At B it says determine the absolute minimum value of f on the closed interval 0 to 8 and then justify your answer. So we have to find the absolute minimum value. So in order to find the absolute minimum value, so what we're going to do is, we know that in order to find any absolute minimum or maximum, we have to consider the endpoints. And since we're trying to find the minimum value, we are going to use the local minimum we have. So we have x, so we do the tables to make it more convenient. And then we have the endpoints as 0 and 8. So we have 0 and 8, and the minimum value, local minimum value, is 6. We got it from there. And then now we are trying to find f of 0. So f of 0, the fundamental theorem, and we know, alright, so we know that f of 0, we have to use the fundamental theorem, which is initial conditions. So f of 8 plus 8 to 0, then f prime of t dt. Now here, so we have this, and now on the question it gave us f of 8. F of 8 is 4. So we're gonna write f of 8 is 4 plus so since we're going reverse, we're gonna try to make it from 0 to 8. So, and you know, when you switch this to, the sign also changes. So it goes from 0 to 8, and the positive becomes negative, and now we still have our f prime of t dt. So it's 4 minus, so f prime of t dt is, so look at this, 0 to 8. It's 2 plus 6 is 8, minus 3 is 5, 5 plus 7 is 12. So we have 4 minus 12 is negative 8. So let me get my eraser. Oh my gosh. Yes. So f of 0 is negative 8. This is how we got it. f of 0 is negative 8. So the same process we use for f of 8, I mean, no, we don't have to use it because f of 8 is given to us. So f of 8 we know is 4, and f of 6 we use the same process and get 4 plus 8 to 6 f prime of t dt. We're gonna change this too, so we're gonna also change the sign. So you get 6 to 8 f prime of t dt. Gonna go cut the process, and it turns out to be 3, negative 3. Okay, so we have 3 values, and the minimum is negative 8. So for the justification, we're gonna write at 0 to 8. Remember, we switched from 8 to 0, we switched it. So we're gonna say 0 to 8 is absolute mean, which is negative 8. And yeah, this is our answer to number B. So you get 1 point for this justification, and you get 1 point for showing this integral. So this is 1 point, both of these two are 1 point, and 1 point for considering these points. So yeah, so now we have A, B, and A and B. And now I'm gonna reload this page because I don't want to erase the whole thing. Oh gosh. Okay, so let's see if we can find new. Let's go again. Oh no. So what we have to do is we're gonna have to try to take the eraser. Just erase this whole thing. Okay. So we have for C, it says on what open intervals contained from 0 to 8 is the graph of f both concave down and increasing, and explain your reasoning. For C, it says f of x has to be concave down. So f of x, we know when f of x is concave down when f prime of x is decreasing. So we have to look where f prime of x is decreasing, which is from 0 to 1, and then 3 to 4, 3 to negative 2 actually, and yeah. But it also says, notice that it says concave down and increasing. So f of x is increasing when f prime of x is positive. So this is not gonna be it because this is negative. So we only can consider everything that's above x-axis. So where is f of x? F prime of x, my bad. So we have to look where f prime of x is decreasing and positive. Decreasing because it's concave down, and positive. So it's decreasing and positive on 0 to 1 and 3 to 4. So for our answer, we're gonna write, my bad. We're gonna write 0 to 1 and 3 to 4, f of x is both concave down and increasing, because f prime of x is decreasing and positive. So this is our answer to number C, and you get 1 point for mentioning these two intervals and 1 point for this justification. For D, I guess D says for D, it says the function g is defined by g of x equals to f of x cube. If f of 3 is this, find the slope of line tangent to the graph of g at x equals to 3. So basically what they're asking is they're asking us to find the slope. And we know whenever we need the slope, we need to find the derivative. So we have to find the derivative of g. And this is a very important part because in this problem, is 3 number and you totally, okay, we'll go to it later. So g prime of x is, so we're going to use the chain rule here. 3 f of x so yeah, and then plug them in, and then f prime of x is 4 in here. We get the value from here, so is 4, and then yeah, do the calculation and you get 75, and this is your answer. So you get 1 point for writing 75 doing the calculation correct, but you get 2 points for showing that you know that you have to do g prime of x. So anytime they're asking for slope, we're doing g prime of x, and that's the answer.